Welcome to the Q&A session 21 from the playlist of electric charges and fields. The topic is the simple harmonic motion of a charge, and based on this topic I have selected one question from NCERT exemplar, and the question is: two charges minus q are separated by a distance 2d. A charge q of mass m is placed at the midpoint. A charge q is displaced by x perpendicular to the line joining the two charges minus q. The time period of the simple harmonic motion of the charge q is, we have to find the time period of the simple harmonic motion of the charge q, and here the displacement is very less in comparison to d. So based on this question, I have already drawn here one simple diagram in which the charges minus q are placed at the point A and B in free space, and the separation between these two charges, that is minus q and minus q, is equal to 2d. Now a charge q of mass m is placed at the midpoint. Midpoint means that it is placed on the line joining the charges minus q and minus q at the midpoint, and this charge q is displaced by a certain distance x perpendicular to the line joining the charges minus q. So in this case, the time period of simple harmonic motion of the charge q has to be found out. So when the charge q is displaced from its mean position, which is the center point of this line AB, to the point Q, to the point P. This charge will come to this point P, which is at a distance x from its mean position, that is O. Then it will be experiencing the attractive force because of this charge minus q placed at A, and it will also experience an attractive force due to the charge minus q which is placed at B. Now I am taking this angle, that is angle APO, as theta, and this triangle AOP and triangle POB are similar because OA is equal to OB and OP is common to both the triangles. So since AOP and this is triangle. Since triangle AOP and triangle POB are similar, and therefore this AP will be equal to PB, and AP will be equal to PB, and this will be equal to under root x square plus d square by using the Pythagoras theorem. So now the attractive force on the charge q due to the charges minus q at A and the charge minus q at B will have two components, means, or we can say that the attractive force which will be directed towards A and B can be resolved into two components. One will be horizontal like this, and the other one will be vertical, and it will be directed towards O, that is, it will be directed towards the mean position of the charge q. Similarly, the attractive force because of this charge minus q which is placed at B, its horizontal component will be directed as indicated by this arrow, and the vertical component will be directed towards the mean position, that is O. And these two horizontal components will cancel out each other because the magnitude of the attractive force, because this charge minus q which is placed at A and this attractive force, the magnitude of the attractive force due to the charge minus q which is stationed at B, are equal. Because why it is equal? Because the magnitude of both these two charges are the same, and the distance between them is also the same. So the attractive force due to the charge minus q which is stationed at A, I am just denoting it as Fa, will be equal to the attractive force due to the charge minus q which is stationed at B on the charge q will be equal to 1 by 4 pi epsilon naught into q square by r square, where r is the distance separating these two charges, which is equal to under root of x square plus d square. Now the vertical component of this attractive force due to the charge minus q at A and due to the charge minus q at B will be equal to Fa cos theta plus Fb cos theta, where theta is the angle APO, and since this angle APO is theta, so this angle this OPB, this will also be equal to theta, because both these triangles are similar, so both these two angles will also be equal. Now cos theta, the value of cos theta can be substituted as base upon hypotenuse, that is x upon this is equal to under root x square plus d square. So the vertical component, the vertical component towards the mean position, that is O, will be equal to this value, and this can be written as cos theta will be equal to x upon under root x square plus d square. So since Fa is equal to Fb, so I will be simply writing the value as 1 by 4 pi epsilon naught into q square divided by r square, which will be equal to x square plus d square into, this is the value of Fa, into cos theta. Cos theta will be equal to x upon under root x square plus d square. So from here, and the value of Fb will also be the same, so this will be 2 times. So the total vertical component, or you can say the total vertical force acting on this charge q towards its mean position is equal to this value. And the horizontal component of these two attractive forces will cancel out each other because they are acting in opposite direction. They are acting exactly in opposite direction, so therefore they will cancel out each other. Now here, so from here, the total vertical force can be now written as 2q square divided by 4 pi epsilon naught, and this is x square plus d square, and this is x square plus d square under root. So this can be written as 1 by 2. So this will be equal to x square plus d square to the power 3 by 2 into x, and this is the net force acting on the charge q towards its mean point. Now since now as per the simple harmonic motion, a particle will execute the simple harmonic motion only when the net force acting on it is directly proportional to the displacement, and the net force should be acting towards its mean position. So here in this case you can see here, that is the net force acting on the charge q is directly proportional to x. Now we will see here whether it is directly proportional to x or not. So since x is very less in comparison to d, so we can ignore the value of x in this equation. So if we ignore the value of the x in this equation, then f will be equal to 2q square divided by 4 pi epsilon naught, and this will be equal to d cube into x. So this is the net force acting on the charge q towards O, which is the mean position of the charge q. So from here we can see that the net force acting on the charge q is directly proportional to x, because 2q square upon 4 pi epsilon naught into dq is a constant. D is a constant, pi is a constant, 4 is a constant, 2 is a constant, q is a constant, and epsilon naught is a constant value. So F is directly proportional to x, the first thing. Second thing, this force F can also be written as K into x, where K will be equal to q square divided by 2 pi epsilon naught into dq. Because this is a constant, K is a constant. Now, so here F, the net force acting on the charge q, is directly proportional to the displacement of the charge, and since we are getting this equation of force in the form F is equal to kx, therefore the this is the first thing. Second thing is that here the net force is directly proportional to the displacement of the charge. So we can say that the particle will definitely execute the simple harmonic motion, and its time period t will be equal to 2 pi under root m upon. This is the time period of a particle executing simple harmonic motion, where m is the mass of the particle, k is the constant here, which is equal to q square upon 2 pi epsilon naught dq. So time period will be equal to 2 pi under root here. Now m upon k, now k is equal to q square upon 2 pi epsilon naught dq. So this 2 pi epsilon naught dq will come in the numerator. So this equation will become 2 pi m epsilon naught dq divided by q square divided by q square. So this is the value of the time period which we have got. So the time period of this charge q will be equal to 2 pi under root 2 pi m epsilon naught dq upon q square. This is m, yes, and this q square upon 2 pi epsilon naught dq, yeah. So this is the correct answer. So first thing is that this charge will definitely execute a simple harmonic motion, because the net force acting on it is directly proportional to the displacement, and at the same time this net force is acting towards its mean position. So thank you very much for joining this session. In the next session I will be coming up with a different topic from the same chapter, that is electric charges in field. So till then, have a nice day. Bye.